Our solar system has long appeared to us as a known and charted territory. Its planets orbit their star on familiar, predictable paths, adhering to the timeless laws of celestial mechanics. Yet into this cosmic order a visitor arrived, silent and unannounced, a wanderer from depths we do not know. This traveller, which came to be known as ATLAS, was not from our world. It had journeyed from another star, carrying with it a message from a distant and unknown system. Its very existence was a revolutionary discovery, a tangible piece of evidence that our solar system is not an isolated island, but part of a much larger galactic current. This interstellar nomad had travelled through the void for perhaps millions of years, gliding through the profound darkness that separates the stars. Its journey had been solitary and silent, until it was finally drawn into the gravitational embrace of our own sun, which pulled it inexorably into the neighbourhood of our planets. Astronomers, keeping watch at their telescopes, first detected this faint point of light approaching, and soon realised it was no ordinary comet or asteroid. Its trajectory was different, an open and elongated path that would never return to its origin, but would instead slice through our solar system just once, before continuing its journey back into deep space. As its orbit was calculated with greater precision, the object's true nature was revealed. Unlike the bodies of our solar system, which circle the Sun in closed, elliptical orbits, the path of ATLAS was distinctly hyperbolic. This mathematical signature was like a seal, confirming its origin from the space between the stars. It was a guest on a journey of passage. Every observation and each new measurement reinforced this extraordinary conclusion, sparking a sense of awe and countless questions within the scientific community about its distant home and the long voyage it had undertaken. This object did not just breach the boundaries of our solar system, but also the limits of humanity's previous understanding of the universe. The presence of this mysterious arrival was like a physical connection to another world, another star system about which we knew nothing. It was a fragment of a foreign reality, carried untouched across the cosmos for eons, now here for us to observe. It held within it the secrets of its faraway home.
What kind of star it had formed around, what its own solar system might have been like, and what forces had ultimately sent it on this incomprehensibly long pilgrimage. Atlas was not merely a celestial body, it was a time capsule, an enigmatic emissary that silently testified to a galaxy filled with connections and stories, still waiting to be discovered. As astronomers began to chart its celestial journey, the first truly alien characteristic of ATLAS to be revealed was its velocity. It was moving with a staggering swiftness, a speed so immense that it seemed to disregard the familiar gravitational cadence of our solar system. Native objects born of our Sun's own protoplanetary disk travel in a relatively predictable and harmonious dance, their speeds governed by their distance from the Sun. Atlas, however, tore through this space with an energy that could only have been acquired from outside, a momentum that set it apart as a true interstellar fugitive, forever unbound by the gravitational laws of our home. This incredible velocity was more than just a measurement. It was a ghost of a past that we could only imagine, a residual echo from its home star system. Such a speed suggested a violent or chaotic origin, hinting that ATLAS had not simply drifted away from its star, but was likely flung into the interstellar void by a powerful gravitational event. Perhaps it was ejected by the immense pull of a giant planet, or cast out during the turbulent formative years of its own solar system. Its journey through our celestial neighborhood was not a gentle visit, but the fleeting passage of a survivor, a silent witness to a distant cosmic drama whose script was unknown to us. Yet beyond its breathtaking speed, an even deeper mystery lay locked within the very substance of ATLAS, an enigma that began to unfold as the object drew closer to the warmth of our Sun. Typically, when a comet approaches a star, its frozen core begins to sublimate,
releasing a vast cloud of gas and dust known as a coma. By analyzing the unique spectrum of light that shines through this glowing shroud, scientists can read the chemical story of the object's heart. For generations, we had come to understand comets as dirty snowballs, celestial bodies composed primarily of water ice mixed with dust and rock, a recipe common to the outer reaches of our own solar system.
Yet, beyond its breathtaking speed, an even deeper mystery lay locked within the very substance of ATLAS, an enigma that began to unfold as the object drew closer to the warmth of our sun. Typically, when a comet approaches a star, its frozen core begins to sublimate, releasing a vast cloud of gas and dust known as a coma. By analyzing the unique spectrum of light that shines through this glowing shroud, scientists can read the chemical story of the object's heart. For generations, we had come to understand comets as dirty snowballs, celestial bodies composed primarily of water ice mixed with dust and rock, a recipe common to the outer reaches of our own solar system. As the spectral data became clearer, the true nature of ATLAS's chemical anomaly was revealed in stark and unambiguous detail. The coma surrounding its nucleus was not the familiar, ethereal glow of sublimating water vapor that astronomers had observed for centuries. Instead, the object's atmosphere was overwhelmingly dominated by carbon dioxide, a compound that, while present in our own comets, had never been seen as the primary component. The measurements were astonishing, indicating that for every molecule of water released, nearly 8 molecules of carbon dioxide were escaping into space, a ratio that completely inverted the known chemistry of comets and pointed to an origin story written in a profoundly different cosmic language. This chemical signature was a direct message from the object's birthplace, a clue that allowed scientists to paint a picture of the environment where it was formed. For carbon dioxide to become the primary frozen material of a celestial body, it must have been created in a region of space that was extraordinarily and persistently cold, far colder than the Kuiper Belt or the Oort cloud where our own comets originate. In the deep freeze of this distant, alien stellar nursery, temperatures were so low that carbon dioxide gas would have frozen solid onto dust grains long before water vapor could condense, making it the fundamental building block of this interstellar wanderer. Atlas was, in essence, a dirty, dry ice ball, a relic from the truly frigid frontiers of another star's domain. This unique composition also explained some of Atlas's unusual behavior as it journeyed through our solar system. Carbon dioxide sublimates, turning directly from a solid to a gas at a much lower temperature than water ice, around -78 degrees Celsius. This meant that Atlas would have begun to show activity, developing its coma and tail, much farther out from the Sun, where the solar radiation is incredibly weak. This early awakening made it appear brighter than a typical water ice comet at such a great distance, which was likely a key reason why it was detected on its long, inward trajectory. Its very substance was tuned to a colder existence, making it come alive in a region where our own comets remain dormant and frozen. The discovery of this carbon dioxide-rich world was more than just a curiosity. It was a fundamental shift in our understanding of how planetary systems can form. It suggested that the chemical inventory available for building comets, asteroids, and even planets can vary dramatically from one star system to the next, depending on the specific conditions of their protoplanetary disks. Our solar system's blueprint, with its water-rich comets, was clearly not the only model in the galaxy. Atlas served as a profound reminder of cosmic diversity, a tangible piece of evidence that the universe is not uniform, but is instead a vast and varied tapestry of countless different chemical and physical possibilities. As Atlas continued its silent, inexorable journey through our solar system, its trajectory was precisely calculated, revealing a path that would bring it to a momentous intersection. The object was not merely passing through the void between the planets, but was set to make a relatively close approach to another world, Mars. In July of 2025, this interstellar traveller would glide past the red planet, offering a rare and tantalizing opportunity to study it in the vicinity of another planetary body. This cosmic rendezvous held the promise of new discoveries, a chance to observe how this alien object might interact, even subtly, with the Martian environment,
its thin atmosphere, and its gravitational field. The scientific community watched with anticipation as the date of this encounter drew ever closer.
However, the universe, in its grand and indifferent design, had arranged a profound and frustrating challenge for this exact moment. Just as Atlas was set to make its pass by Mars, the Earth, Mars, and the Sun would align in a configuration known as solar conjunction. From our vantage point on Earth, both the interstellar object and the planet Mars would swing directly behind the Sun, disappearing into the blinding glare of our own star. For a crucial period, the Sun would act as an immense celestial curtain, effectively blinding all of our Earth-based telescopes and cutting off our direct line of sight to this extraordinary event. It was a moment of cosmic irony, as the most anticipated chapter of Atlas's visit was destined to unfold on a stage that we could not see. The consequences of this celestial alignment were absolute, creating a blackout in our observational capabilities. The faint, reflected light from ATLAS, already a significant challenge to detect across hundreds of millions of kilometers, would be completely overwhelmed and washed away by the torrent of radiation pouring from the Sun. It was as if the universe was deliberately shielding this encounter from our eyes, shrouding the interaction between the interstellar visitor and the red planet in a veil of impenetrable light. This period of blindness meant that the crucial data, the subtle changes in its coma, the potential outgassing triggered by its proximity to a planetary body, the precise gravitational deflection, would all be lost to us, at least through our traditional means of observation. This unavoidable observational gap created a profound sense of suspense and helplessness, forcing humanity to wait in the dark as this unprecedented event transpired. The timing seemed almost too perfect to be a mere coincidence, raising questions that lingered in the quiet halls of observatories around the world. As Atlas prepared to make its closest approach to Mars, we on Earth were left to wonder what might be happening in that hidden corner of the solar system, unseen and unheard. Our most powerful eyes were turned away, compelling us to rely on silent, pre-programmed sentinels already in orbit around the very planet that was about to host this mysterious visitor.
Meanwhile, on the silent ochre plains of the red planet, another story was unfolding, entirely separate from the celestial drama of the approaching interstellar visitor. For years, NASA's robotic explorers had been patiently toiling away on the Martian surface, acting as our remote geological eyes and hands. One of these, the Perseverance rover, was methodically carrying out its mission in a place of immense scientific interest, the Jezero crater. This vast, ancient basin was chosen for a specific reason, as scientists believed that billions of years ago it held a deep, tranquil lake fed by a winding river that built a great delta, precisely the kind of environment where the first signs of life might have emerged and been preserved. It was within the fine-grained sedimentary rocks of this ancient river delta that the rover's sophisticated instruments began to detect something remarkable. While drilling into the Martian crust and analyzing the powdered samples, the rover's sensors registered faint but persistent chemical traces that could not be easily explained by geology alone. These were potential biosignatures, subtle molecular or isotopic patterns that, on Earth, are typically associated with biological processes. While not definitive proof of life, these findings were incredibly tantalizing, representing the most compelling evidence yet that Mars may not have always been the sterile, barren world it appears to be today. The discovery sent quiet waves of excitement through the scientific community back on Earth, a momentous finding in its own right, but its significance was magnified 1,000 times by the cosmic timing of its announcement. It was in this very window of time, as the silent interstellar wanderer ATLAS was bearing down on Mars, that humanity's own robotic emissary was uncovering potential signs of ancient life on that exact same world. Two completely independent narratives of immense importance, one from the deepest reaches of interstellar space, the other from the deepest layers of Martian rock, were converging on a single point in space and time.
This extraordinary alignment of events, occurring while Earth was conveniently blinded by the sun, gave rise to a question that echoed with profound implications, moving beyond the realm of simple astronomy and into something far more contemplative. Was this merely a staggering coincidence, a 1 in a billion chance alignment of two unrelated cosmic events? Or was there a thread, invisible and unknown, that somehow connected the arrival of this strange, carbon-rich messenger with the ancient secrets being unearthed from the Martian soil? The universe, it seemed, was presenting a riddle wrapped in an enigma. This convergence of events, unfolding in the silent theatre of the cosmos, forced a profound question upon those who were watching. It was a question that transcended simple scientific inquiry and touched upon the very nature of our place in the universe. Was this confluence of a mysterious interstellar visitor, the discovery of potential life signs, and the perfectly timed celestial blackout merely a random accident? It seemed to stretch the very limits of probability, creating a narrative so perfectly constructed that it felt less like a product of chance and more like a chapter from a carefully written story, whose author and purpose remained completely unknown. The first and most rational explanation was that of a simple, albeit extraordinary, cosmic coincidence. In the immense vastness of space and across the deep expanse of geological time, improbable events are not just possible, but statistically inevitable. The universe does not operate with a sense of narrative or drama. It is governed by the cold, impartial laws of physics and chemistry. From this perspective, the arrival of ATLAS was an event completely independent of the slow, patient work of a rover on Mars. Their intersection in time and space was a beautiful, yet ultimately meaningless, alignment of two separate and unrelated stories, a chance occurrence that we, as pattern-seeking beings, were attempting to imbue with a significance that it did not possess. A second possibility, however, offered a subtle bridge between these two seemingly disparate events, suggesting a connection that was natural rather than coincidental. This was the idea of ATLAS as a natural delivery system, a carrier of the raw materials that could potentially foster life. Its unusual carbon dioxide-rich composition made it a vessel of exotic ices and organic precursors, materials that might be rare in our own solar system, but essential for the chemistry of life to begin. In this scenario, Atlas was not a targeted messenger, but simply one of countless natural seeds drifting through the galaxy, a random delivery of the building blocks of biology to a world that may have once been fertile ground, a process known as panspermia. And finally, there lingered the most speculative and profound possibility, the one that whispered of intention. This was the idea that the event was not random at all, but was in some way designed, a carefully orchestrated set of circumstances for a purpose we could not yet fathom. This line of thought did not necessarily imply a conscious sender in the way we understand it, but it opened the door to a universe where events might be connected by a logic that lies beyond our current comprehension. It framed the arrival of Atlas not as an accident, but as a deliberate act, a message or a tool sent across the interstellar void to intersect with Mars at this precise and pivotal moment in its exploration. Amidst the swirling storm of questions and the profound mysteries surrounding its composition and purpose, there was one singular truth about ATLAS that stood firm, unassailable and absolute. This certainty was not derived from speculative theories or ambiguous chemical readings, but was written in the cold, elegant language of mathematics, the universal script of the cosmos. The path it carved through our solar system was not the closed, repeating loop of a planet or a native comet, but a wide, open arc known as a hyperbola. This was not merely a description of its trajectory, it was a mathematical verdict, an irrefutable proof that this object was not, and had never been, a member of our solar family. For centuries, our understanding of the heavens has been built upon the foundation of orbital mechanics, a science that reveals the gravitational story of any object in motion. The planets and asteroids of our solar system are captives of the Sun, their paths forever bound into elliptical orbits destined to circle their star for eternity. A hyperbolic orbit, however, tells a very different story. It is the signature of an escapee,
a traveler with so much energy that no star can hold it. It is the path of an object that arrives from infinity and is destined to return to infinity, its trajectory bent but never broken by the gravity of the star it passes. This mathematical confirmation transformed Atlas from a mere curiosity into a confirmed emissary from another star. It was the first piece of solid ground in a vast sea of speculation, a fact upon which all other theories had to be built. While we could debate the meaning of its chemical signature or the purpose of its arrival, there was no debating its home. It came from the void between the stars, having crossed an unimaginable chasm of space to reach us. This fact alone fundamentally altered our perception of the galaxy, shattering the illusion of our solar system as a secluded, isolated island and revealing it to be a coastline on a vast, interconnected cosmic ocean.
The certainty of its path also cast the object's other qualities in a new light. Its incredible speed and its alien composition were no longer just anomalies. They were now understood as characteristics of a world formed in a completely different stellar environment. The hyperbolic orbit was the anchor that connected all the other strange and unprecedented facts about this visitor, giving them a coherent context. It was the key that unlocked the first and most fundamental secret of Atala's, that we were not just observing a comet, but were bearing witness to a tangible piece of another solar system, a silent ambassador that had journeyed for eons to briefly grace our own. Flowing directly from the mathematical certainty of its hyperbolic orbit was the staggering physical reality of its speed. Atlas was moving at approximately 68 kilometers every single second, a velocity so immense it is difficult for the human mind to truly comprehend. This was not the leisurely, looping pace of a planet, or the predictable arc of a native comet falling toward the sun. It was the relentless, driving speed of a projectile, a body possessing a kinetic energy that dwarfed anything originating from our own celestial neighborhood. This immense velocity was the physical expression of its interstellar freedom, the very force that allowed it to break the gravitational chains of its own star and travel the unfathomable distances between worlds. This speed was more than a mere number. It was a ghost of the object's past, a residual echo of the cataclysmic event that must have launched it on its journey. Objects are not simply born with this kind of momentum. Such a velocity could only be imparted by an immense gravitational disruption, suggesting that Atala's was violently ejected from its home system. Perhaps it was flung into the void by the powerful gravitational pull of a migrating gas giant, or cast out during the chaotic, formative years of its solar system. Its incredible speed was therefore a scar, a permanent testament to a distant and tumultuous history, a silent story of exile written in the language of motion. To witness this velocity from the perspective of our solar system was to observe a profound contrast in cosmic dynamics. Our own celestial bodies move in a stately gravitational dance, a slow and predictable choreography set in motion billions of years ago. Their speeds are a measure of their subservience to the sun. Atlas, however, tore through this delicate and ancient ballet like a bullet through a quiet room, its motion governed by a completely different set of initial conditions. It was a visitor, whose fundamental state of being was incompatible with the gentle rhythm of our system. A traveler that did not have the luxury of slowing down to linger. Its journey through our realm was therefore destined to be a fleeting one, a brief and transient passage. This incredible speed meant that its encounter with our solar system would last for only a few short years, before it was once again reclaimed by the interstellar darkness from which it came. Every moment of observation was precious, every measurement a race against its rapid departure. The clock was always ticking, counting down as this high-speed emissary followed its calculated path, a path that was now bringing it ever closer to the inner solar system, and to its eventual closest encounter with our own planet. After its dramatic and unseen passage by Mars, the trajectory of Atlas would carry it onward, deeper into the inner solar system,
on a path that would bring it to its next significant milestone. This time, the encounter would be with our own world. Calculations showed that in December of 2025, the interstellar wanderer would make its closest approach to Earth, a moment that would mark the culmination of its journey from our perspective. This event, however, was not one of impending danger, but of distant greeting. The object was not on a collision course, but was merely a passerby, a temporary neighbour in the vastness of space, destined to offer us our clearest, most direct view of its alien form.
The distance of this encounter, however, underscores the true scale of the cosmos. At its nearest point, Atlas would still be approximately 269 million kilometers away from Earth, a chasm of empty space so vast that it is almost beyond true comprehension. This is a distance far greater than that which separates the Earth from the Sun, meaning that even at its closest, the visitor would remain a remote and solitary figure on the celestial stage. There would be no dramatic looming presence in our skies, only a faint star-like point of light, visible only through the powerful eyes of our telescopes. This immense gap was a silent reminder that this was an encounter of observation, not of interaction, a meeting of two worlds across an unbridgeable void. Despite the great distance, this closest approach represented the most critical opportunity for humanity to study the object directly. By December 2025, Atlas would have moved out from behind the Sun's glare, becoming a prime target for the world's observatories. As it absorbed the Sun's energy, its outgassing would likely be at its peak, providing the brightest and most detailed view of its coma and the exotic chemistry within. This window of time would be a period of intense, coordinated observation, a global effort to capture every possible photon of light from this fleeting visitor, in the hope of unlocking the secrets of its unprecedented composition and its distant, unknown origin. This moment was therefore imbued with a sense of profound and final opportunity. It was humanity's one best chance to interrogate this silent messenger before it began its long, lonely journey back out into the cold and the dark from which it had come. After this encounter, its path would carry it away from the Sun, and as it receded, it would begin to fade. Its activity would diminish, and it would slowly transform back into a faint and silent ghost, eventually disappearing from our view forever. The secrets it held would either be revealed in this brief, luminous moment, or they would be carried away, back into the endless night between the stars.
For as long as humanity has studied the heavens, comets have been a source of both wonder and mystery. Ancient wanderers carrying the primordial story of our own solar system's birth. Through centuries of observation, we have come to understand these celestial visitors with a familiar and elegant model, a concept known as the dirty snowball. This idea posits that comets are essentially cosmic relics, loose aggregations of water ice, dust and rock, forged in the deep freeze of the outer solar system billions of years ago. They are, in essence, pristine samples of the original material from which the planets themselves were formed, preserved in the cold and the dark. Their long, elliptical orbits carry them from the frigid outer darkness of the Kuiper Belt and the Oort cloud on epic journeys toward the inner solar system. As a comet approaches the Sun, the star's warmth begins to touch its frozen surface, causing the water ice to sublimate, transforming directly from a solid into a gas. This release of water vapor, mixed with the dust it carries, creates a vast glowing atmosphere around the nucleus called a coma, which is then sculpted by the solar wind into the long ethereal tails that can stretch for millions of kilometers across the sky. This release of water is the very engine that drives the magnificent spectacle of a comet, the source of its transient and ghostly beauty. This understanding is far more than a simple analogy. It is a cornerstone of planetary science, a model that has been confirmed time and again by meticulous spectroscopic analysis and even direct encounters by robotic spacecraft. By studying the light that passes through their comas, we have consistently found the unmistakable chemical signature of water as the dominant volatile compound. This familiar chemistry connects these objects directly to our own cosmic history, identifying them as native children of our Sun, born from the same protoplanetary disk as Earth itself. Their story, written in water, is a story we have learned to read with confidence.
It was against this backdrop of well-established certainty that the enigma of ATLAS presented itself, for this interstellar visitor refused to adhere to the familiar script. The dirty snowball model, which had so reliably described every comet we had ever known, simply did not apply. As astronomers turned their instruments toward this approaching object, they fully expected to see the familiar spectral lines of water vapor beginning to appear as it warmed. But the story Atlas began to tell was profoundly different. A chemical narrative that spoke not of the familiar processes of our own solar system, but of a vastly different and much colder place of origin. As the first spectral readings from the coma of ATLAS were processed, the data painted a picture that was utterly alien and unprecedented. Where astronomers expected to see the dominant, familiar signature of hydroxyl radicals, the telltale byproduct of water vapor being broken apart by solar radiation, they instead found a spectral landscape dominated by a different molecule entirely. The light filtering through the object's nascent atmosphere was saturated with the unmistakable fingerprint of carbon dioxide, confirming in stark, unambiguous detail that this was the primary gas driving its activity. The dirty snowball model, the very foundation of cometary science, had been shattered by a single, irrefutable observation. This discovery fundamentally redefined the nature of the object.
Atlas was not a cosmic snowball, but something far colder and more exotic. A dirty, dry ice ball. This chemical identity was a direct message from its birthplace, a clue that allowed scientists the journey, in their minds, to the environment where it must have been forged. For carbon dioxide to become the chief component of a celestial body, that body must have formed in a region of space that was profoundly and persistently cold, a place far more frigid than the outer realms of our own solar system. It was a relic from a stellar nursery where the ambient temperature was so low that carbon dioxide froze solid long before water could, becoming the bedrock of its creation. This unique composition had profound physical consequences that explain some of Atlas's peculiar behavior. Carbon dioxide turns from a solid directly into a gas at a much lower temperature than water ice, meaning that Atlas began to stir and show signs of life much farther out from the Sun, in a region where the Sun's warmth is almost imperceptible. This early awakening, driven by its dry ice engine, caused it to brighten and develop its coma while still deep in the outer solar system, a key reason why it was spotted on its long inbound journey. It was a creature of the extreme cold, coming alive in a zone where our native comets remain frozen and dormant. The existence of such a carbon dioxide-rich object was more than just a scientific curiosity. It was a testament to the sheer diversity of the cosmos. It provided the first tangible proof that the chemical recipes for building planetary systems can vary dramatically from one star to the next, shaped by the unique conditions of their formative environments. Our solar system, with its water-rich comets, was clearly not a universal template. Atlas was a messenger, carrying within its frozen heart the formula for a different kind of world, silently testifying to the fact that the galaxy is a vast and varied tapestry of countless chemical possibilities.
The discovery of this chemical makeup was more than just a classification. It was a form of cosmic archaeology, allowing us to reconstruct the environment of the object's birth. Different molecules freeze out of a gaseous state at vastly different temperatures,
acting as a kind of celestial thermometer that records the conditions of a bygone era. In our own solar system's outer fringes, where our comets were born, it was cold enough for water to freeze, but not consistently cold enough for carbon dioxide and other more volatile gases to become the dominant building materials. The composition of Atlas, with its overwhelming abundance of frozen carbon dioxide, therefore served as a direct and unambiguous reading from this cosmic thermometer, pointing to a birthplace of unimaginable cold, a region of space far more frigid and remote than any we have directly observed. We are thus compelled to imagine a place in a distant and unknown protoplanetary disk, a gloomy frontier orbiting a star we have never seen. In this realm, the parent star would have been but a faint point of light, its warmth barely reaching across the vast expanse, leaving the building blocks of worlds in a state of profound and perpetual deep freeze. Here, in the absolute silence and the near absolute cold, the slow and patient process of creation would have followed a different set of rules, governed by the chemistry of this extreme environment. It was in such a place, a cradle of ice and shadow, that the object we call Atlas was slowly and carefully assembled, molecule by molecule, over millions of years. In this frigid nursery, carbon dioxide would have been the primary snow, the most abundant frozen material available to accrete onto the primordial dust grains that drifted through the disk. While water is one of the most common molecules in the universe, it would have remained a gas or a minor frozen component in a place where the deeper cold favored the solidification of other compounds first. This explains not just what a talus is, but why it is the way it is. Its entire formation story is fundamentally different from that of our native comets, making it not just a visitor, but a genuine artifact from a completely different kind of celestial factory, a testament to a creation story written with an entirely different chemical ink.
And so, this ancient relic, having preserved the pristine memory of its ultra-cold home within its very being, travelled for eons across the interstellar void. Its journey was a long, silent sleep, perfectly preserving the conditions of its birth until it was finally awakened by the faint warmth of our own star. Now, as this fragment from an alien deep freeze continued its journey inward, its path was set to carry it past a world that holds its own ancient secrets, mysteries that are not frozen in its composition, but are locked away in the layered, rusty dust of its silent craters. While the story of Atlas was being written in the cold, empty canvas of space, a parallel narrative was being painstakingly uncovered, grain by grain, in the ancient, rusty dust of Mars. For years, humanity's robotic emissary, the Perseverance rover, had been methodically exploring the floor of the Jezero crater, a location chosen with singular purpose. This vast basin, scientists believe, was once a deep and placid lake, fed by a river that carved a sprawling delta into its rim. It was a place of water and sediment, an environment that billions of years ago might have possessed all the necessary ingredients for life to emerge and, crucially, for its faint traces to be preserved through the eons. It was here, within the fine-grained layers of this fossilized river delta, that the rover's instruments began to reveal something extraordinary, a pattern that defied simple geological explanation. As Perseverance drilled into the sedimentary rock, its cameras and sensors analyzed the textures of these ancient stones, revealing peculiar, spotted formations embedded within the layers. Nicknamed leopard spot patterns by the science team, these were not random discolorations, but structured, clotted arrangements that suggested a process more complex than the mere settling of dust and sand. They were an organized anomaly, a quiet whisper from the deep past, hinting that something other than wind and water had been at work here.
This discovery resonated with a profound and ancient question, because these patterns bore a striking resemblance to structures found on Earth that are known to be the work of life. Specifically, they looked like microbialites, which are layered rock formations created by the growth of vast colonies of microorganisms in shallow water. Over time, these mats of bacteria trap and bind sediment, creating distinctive, clotted textures that become preserved in the rock record as a definitive sign of past biological activity. The Martian spots were not proof, but they were a tantalizing echo, a geological ghost that fit the profile of a biosignature, the most compelling evidence yet that Mars may not have always been a dead world. And so, two immense and separate mysteries were converging upon a single, unsuspecting planet. From the outside, the interstellar wanderer ATLAS was approaching, a carrier of alien chemistry from a distant star. And from within, the planet itself was beginning to surrender its own profound secrets, hints of a possible biological past locked away in its stone heart. The timing was staggering, a cosmic synchronicity that seemed almost too perfect to be random, setting the stage for the moment when these two great unknowns would finally intersect. The climax of this drama was now set for the close approach of ATLAS, a flyby that promised to bring the visitor almost to the planet's doorstep. As the Martian autumn began to settle across the red plains of Jezero, the inexorable laws of celestial mechanics were drawing the interstellar visitor ever closer to its planetary rendezvous. The calculated trajectory, refined with each new observation, pinpointed a specific moment in time, October 3, 2025. On this day, Atlas would reach its perihelion, the point of its closest approach to Mars, a fleeting intersection in the vastness of space. The distance of this encounter would be a mere 28 million kilometers, a number that, while immense by human standards, represents an incredibly intimate pass on the scale of the solar system, bringing the alien object almost to the planet's doorstep.
This proximity was not merely a curiosity of orbital dynamics. It was the single greatest opportunity to witness a direct interaction between a piece of another star system and the planet in our own. At such a close range, the faint but persistent gravitational pull of Mars could, in theory, subtly alter the path of Atlas, a gravitational whisper that, if measured, could reveal the object's mass and density with unprecedented accuracy. Furthermore, the tenuous upper layers of the Martian atmosphere and its magnetic field might interact with the visitor's outgassing coma, potentially triggering new chemical reactions or auroral displays that could tell us more about both the object and the planet itself. This was the moment where the two great converging narratives were set to meet upon a single celestial stage. On one side was Mars, the ancient world that was just beginning to surrender its own profound secrets, whispering of a past that may have harbored life. On the other was Atlas, the enigmatic messenger from an unknown ultra-cold realm, a carrier of an alien chemistry that challenged our understanding of how worlds are made. The flyby was the climax of this staggering cosmic coincidence, the point where the riddle of Mars would come face to face with the enigma from the stars, a silent meeting of two of the solar system's most profound unknowns. Yet, in a moment of profound cosmic irony, this perfect opportunity for observation, this scientifically priceless encounter, was destined to be veiled from our eyes. The very laws of physics that had so precisely orchestrated this meeting had also conspired to create the most challenging of circumstances for those who wished to watch. For as Atlas prepared to make its closest pass, an immense and insurmountable barrier was moving into place. A celestial obstacle that would not only hinder our view, but would cut us off from the event almost entirely, leaving humanity to wait in a state of suspended ignorance. This grand celestial meeting, however, was destined to be a private affair, shielded from human eyes by a cosmic arrangement of profound and frustrating perfection. The precise timing of the flyby coincided with an astronomical event known as solar conjunction, a regular and predictable alignment in the dance of the planets. During this period, Mars, on its slower, wider orbit, passes directly behind the Sun from the perspective of Earth. For weeks, our star would position itself as an immense, immovable barrier, a celestial curtain drawn directly between our world and the stage where this unprecedented drama was set to unfold, rendering any and all direct observation from Earth utterly impossible. The Sun is not merely a source of blinding light. It is a raging torrent of charged particles and intense radiation, the solar wind, which pours out in all directions.
Any radio signal attempting to cross this turbulent path would be hopelessly corrupted and lost, and the faint, reflected light from a distant, dim object like Atlas would be completely swallowed by the star's incandescent glare. Earth's most powerful telescopes, the culmination of centuries of scientific progress, would be rendered useless, their gaze unable to penetrate the veil of our own star. It was a moment of supreme irony. The most tantalizing astronomical encounter of a generation would happen in our own celestial backyard. Yet it might as well have been occurring in another galaxy. This celestial alignment did more than just block our vision, it also severed our connection. The same solar interference that blinded our telescopes also silenced our lines of communication to the robotic explorers at Mars. For the duration of the conjunction, no new commands could be sent to the rovers on the surface or the orbiters circling above. And, more importantly, no data could be received from them. Our remote eyes and ears on the red planet would fall silent, operating entirely on their own, following pre-programmed sequences written by their human creators weeks in advance. They would be alone, unwitting witnesses to the flyby, but with no way to tell us what, if anything, they were seeing. And so, humanity was left in a state of profound and enforced ignorance, waiting in the dark as this extraordinary event transpired unseen. The timing seemed almost too perfect to be a mere accident of orbital mechanics, a coincidence so precise that it felt deliberate. The universe had arranged for the arrival of its most mysterious visitor at its most enigmatic planet, and at the very same moment, it had drawn a perfect veil across the encounter. This left only one fragile, desperate hope: the silent sentinels that were already there, the last guardians circling the red planet, who might, if everything went perfectly, catch a fleeting glimpse of the passing ghost. With humanity completely blinded by the sun, all hope for witnessing this silent, cosmic rendezvous shifted from the great observatories of Earth to a small, isolated fleet of robotic sentinels, already circling the red planet. These were our last guardians, our remote proxies orbiting in the cold silence of space, completely unaware of the unique astronomical drama that was about to unfold in their vicinity. Among them were the European Space Agency's veteran Mars Express and the more modern ExoMars Trace Gas Orbiter, machines designed for a different purpose, now unexpectedly recast as the sole watchman for this unprecedented interstellar encounter. They were our only eyes, our last, lonely outposts in the dark.
These spacecraft were never intended for such a task. They were built as planetary surveyors, designed with instruments that were finely tuned to look down, not up. Their primary mission was to map the rusty surface of Mars, to analyze the composition of its thin atmosphere, and to search for the telltale signs of water and geological activity on the world below. To ask these specialized machines to turn their gaze outward, to attempt to track a faint, fast-moving object against the infinite blackness of space, was an immense engineering and navigational challenge, a feat of scientific ingenuity that pushed them far beyond the limits of their original design. Each of these orbiters brought its own unique capabilities to this improbable task. Mars Express, a reliable veteran that has been faithfully circling the planet for 2 decades, offered its steadfastness and the potential of its wide-field camera to perhaps catch a faint glimpse of the visitor's path. The ExoMars Trace Gas Orbiter, however, represented the greatest hope, for it carried a suite of incredibly sensitive spectrometers, instruments designed to sniff out the faintest chemical traces in the Martian air. If these could be successfully recalibrated and aimed at ATLAS, they might just be able to read the chemical story written in its coma, even from millions of kilometers away. And so, the fate of this entire observation rested upon these silent, automated explorers, cut off from their creators and adrift in the vastness of the solar system. They were not mere machines, but the extension of human curiosity, programmed with a ghost of our own intent. The complex commands to reorient themselves, to open the shutters of their instruments, and to stare into the void at precisely the right moment had been sent weeks in advance, a carefully calculated message in a bottle cast across a sea of solar radiation. Now they were on their own, executing those final instructions without any guidance from a silent Earth.
Weeks before the solar conjunction began, the last stream of data was sent from Earth. A final, intricate set of instructions transmitted across the growing distance to Mars. This was an act of profound scientific faith, a carefully scripted plan sent into the future with no possibility for correction or confirmation. Once the commands were received and stored within the orbiter's memories, the connection was severed, leaving the machines to carry out their complex mission in complete isolation. Humanity had cast its final message into the void, a ghost of intent that would awaken only when the interstellar visitor was already passing by. And so, on the appointed day, a silent and solitary ballet would begin in the darkness above the red planet. Without any guidance from their distant creators, the orbiters would have to execute their instructions with perfect precision, their internal clocks counting down to the critical moment. They would carefully pivot, turning their delicate instruments away from the familiar face of Mars and toward a precisely calculated, empty point in the star-filled blackness. It was through this cold, pre-calculated patch of sky that ATLAS was predicted to travel, a fleeting shadow that the automated sentinels had been programmed to intercept. Each line of code in these pre-programmed sequences represented a human decision, a complex calculation based on the best available predictions of the visitor's path and brightness. The orbiters were acting as vessels for this stored intelligence, executing a plan without any awareness of the profound significance of their actions. They were our proxies, our blind hands reaching out across the solar system, following a script that had been written for a play they could not see. Their mission was one of pure, unthinking obedience to a logic that was, by then, millions of kilometers and several weeks in the past.
After the flyby was complete, their programming would instruct them to turn back to their primary tasks, their memory banks holding whatever precious data they may have collected. This information, however, would remain a secret, locked away in the silence of space, awaiting the end of the solar conjunction weeks later when a signal could finally be sent home. But even as humanity waited, a deeper uncertainty remained, for the success of this automated observation depended entirely on the immense challenge of the task itself, a task defined by the visitor's extreme faintness and the inherent limitations of the machines sent to find it. The success of this automated vigil, however, was far from guaranteed, hanging by the thinnest of threads against the immense challenges of the cosmos. The first and most fundamental of these obstacles was the profound faintness of ATLAS itself. Unlike a star, the object produced no light of its own. It was a small, dark nucleus of ice and rock, visible only by the faint and distant sunlight it reflected back into space. At a distance of 28 million kilometers, this reflected glow would be incredibly feeble, a whisper of light against the profound blackness. A signal so weak it would be perilously close to the detection limits of even the most sensitive instruments. It was a task akin to spotting a single, dark piece of coal from miles away in the dead of night, using only the most distant and gentle of light sources. Compounding this challenge were the inherent technical limitations of the observers themselves. The orbiters around Mars were masterpieces of engineering, but they were built for an entirely different purpose. Their instruments designed to look down upon the bright, sprawling surface of a nearby planet, not up into the deep, empty void. Their cameras possessed wide fields of view, perfect for mapping vast canyons and polar ice caps, but ill-suited for the precise, narrow field tracking required to pinpoint a single, tiny, moving object. It was a case of having the wrong tools for a task that had never been anticipated. Like asking a cartographer to perform the work of an astronomer with instruments that were fundamentally unsuited for the scale of the challenge. These two immense difficulties, the faintness of the target and the limitations of the instruments, were woven together by the final, overarching problem of uncertainty. The commands sent to the orbiters were based on a calculated prediction of where Atlas would be at a precise moment in time. An estimate of a tiny, moving point in a vast, three-dimensional space. Even the smallest deviation in the object's path,
perhaps caused by a pocket of gas erupting from its surface and acting like a minuscule thruster, could be enough to push it just outside the narrow, pre-programmed field of view. Success, therefore, required not just flawless engineering and execution, but a considerable measure of cosmic luck, a perfect alignment of prediction and reality across an unimaginable distance. And so, after the silent flyby was complete, all of humanity was left to wait in a state of profound suspense. The outcome of this desperate observation locked away in the memory banks of machines that could not speak. In this period of enforced silence, the mind was left to ponder the staggering sequence of events. The arrival of the alien messenger, the discovery of ancient secrets on Mars, and the perfect, celestial veil that had been drawn across their meeting. This vacuum of information, this absence of hard data, created a space where the human need for narrative and explanation began to grow, compelling us to take the few, strange pieces of the puzzle we possessed and attempt to assemble them into a coherent story.
In the quiet vacuum of knowledge that followed, with humanity waiting in silence for a message that might never come, the mind inevitably began to search for a framework, a story that could hold these strange and disparate facts together. And in this search for meaning, the first and most powerful explanation to arise was the one that required no story at all. This was the principle of coincidence, the sober and rational acknowledgement that in a universe of unimaginable scale and age, even the most improbable events are not just possible, but are statistically bound to happen eventually. It is the anchor of scientific reason against the powerful tide of human pattern seeking, the quiet insistence that not all that is beautiful or strange is imbued with purpose. From this disciplined perspective, the entire sequence of events, however extraordinary, could be understood as a simple and elegant alignment of three completely independent threads. The first was the random, chaotic journey of ATLAS, a solitary wanderer cast out from its home star by a chance gravitational encounter millions of years ago, its path a product of pure, unguided physics. The second was the patient, methodical work of science, the culmination of decades of planning that placed a robotic geologist in an ancient Martian lakebed at this particular moment in time. And the third was the predictable, clockwork precision of orbital mechanics, the celestial dance that just happened to place the Sun between Earth and Mars at the very same time. There was no connection, no design, only the chance intersection of three separate, unwritten stories. This explanation holds a certain cold and austere beauty, a testament to a cosmos that operates not on narrative, but on the impartial laws of probability and physics. It asks us to accept that the universe is not a storyteller, that it does not arrange events for our benefit or enlightenment, and that meaning is a purely human invention that we project onto a canvas that is, in reality, blank. The convergence on Mars was therefore not a riddle to be solved, but a beautiful, fleeting spectacle to be admired, a rare cosmic alignment that was all the more precious for its complete and utter lack of a deeper significance. Yet, for the human mind, which is so exquisitely tuned to find patterns and craft narratives, this conclusion, for all its logic, feels profoundly unsatisfying. It leaves a void where we crave a purpose, an emptiness where we seek a connection. To accept that this perfect convergence of alien visitor, ancient secrets, and celestial blindness was merely a random accident is to accept a universe that is fundamentally indifferent to our quest for understanding. And so, while reason and probability point firmly toward coincidence, the sheer, poetic perfection of the events compels the imagination to wander down other, less likely paths, to ask the question that hangs, unspoken, in the silence. What if this was not an accident at all, but rather a delivery, as precise and intentional as a message in a bottle sent deliberately to a distant shore? This line of thought leads the imagination down a far more structured and deliberate path, away from the cold calculus of chance and toward the speculative whisper of intention. This is the theory of a planned delivery, an idea that proposes the entire sequence of events was not an accident at all, but a carefully engineered act of cosmic design. In this narrative, Atlas is not a random wanderer but a targeted messenger, a vessel sent across the interstellar void with a specific destination and a profound purpose. The sheer narrative perfection of the encounter, the right object, at the right planet, at the right time, all while humanity's gaze is conveniently averted, is presented not as coincidence but as the signature of a plan, the hallmarks of an event that was meant to happen precisely as it did. If one were to entertain this extraordinary idea, the first and most logical purpose would be that of terraforming, the act of transforming a dead world into one that could support life. From this perspective, ATLAS was not just a comet, it was a perfect atmospheric starter kit, a carefully chosen tool for a planetary engineering project of unimaginable scale. Its composition, so rich in frozen carbon dioxide, would be the ideal payload to deliver to Mars, a world whose primary atmospheric component is also carbon dioxide, but in a concentration far too thin to retain heat. A direct impact or a close fragmenting pass could release this immense cargo, a gift of gas and ice to a dormant world, a first powerful step in thickening its atmosphere and awakening it from its long frozen slumber. An even more profound purpose, however, lies in the concept of directed panspermia, the deliberate seeding of a world with the building blocks of life, or perhaps even life itself. In this scenario, Atlas was not just a tool for changing the environment, but a vessel for delivering the spark, an interstellar ark carrying the precious cargo of biology across the void. The timing of its arrival, intersecting so perfectly with the discovery of potential biosignatures in the ancient Martian soil, gives this theory a particular and resonant power. It suggests that this might not be a first genesis, but a second, a renewal, or perhaps a reinforcement of a biological process that began eons ago and has long since faded. A deliberate act to restart a clock that had stopped ticking. And yet, for all its narrative elegance and its power to connect every strange and unlikely dot, the theory of a planned delivery collides with a single, unmovable wall of scientific fact. A complete and total lack of evidence for any kind of artificial guidance. As astronomers tracked its path with painstaking precision, they found that its motion was perfectly and completely explained by the known natural forces of the cosmos. Its trajectory was a flawless testament to the silent, impartial hand of gravity, with no hint of a thruster's burn, no sign of a corrected course, no deviation from the path that any natural, unguided object would take. The story whispered of intention, but the cold, hard data spoke only of a natural traveller, a ghost adrift on the gravitational currents of the galaxy. And so, if the evidence for a planned delivery remains absent, and the cold hand of coincidence feels too empty, a third and final possibility emerges from the twilight between them. This is the ancient and elegant theory of panspermia, an idea that reconciles the sheer strangeness of the events with the quiet, unguided processes of the natural universe. This theory proposes that comets and other interstellar objects are not targeted messengers, but are instead the galaxy's own unwitting gardeners, the natural carriers of life's most fundamental building blocks. In this narrative, Atlas was not sent, but was simply a part of a much grander, slower, and more ancient cosmic current, a seed cast out from one corner of the galactic garden, destined to drift on the stellar winds until it found fertile soil. In this grand galactic story, a TLAS was not a weapon for terraforming or an ark for living organisms, but something far more subtle. A pristine, refrigerated vessel carrying a precious chemical cargo. Forged in the extreme cold of its own distant stellar nursery, its core would have trapped not just carbon dioxide, but a rich inventory of complex organic molecules, the very same carbon-based compounds that form the basis of all known life. Shielded within its icy heart, These precursors to biology would have been perfectly preserved, protected from the harsh radiation of interstellar space during a journey that lasted for millions of years. Its arrival at Mars was therefore not an act of intention, but the simple, final step of a long and random cosmic delivery. This perspective reframes the entire encounter, shifting it from a singular, unique event into a glimpse of an ongoing, galaxy-spanning process. If panspermia is a reality, then life is not a miraculous accident confined to a few sheltered worlds, but is instead a cosmic imperative, a fundamental property of the universe that is constantly being shared and spread from star to star. The arrival of Atlas was not, then, the beginning or the end of a story, but merely a single, visible moment in an endless and invisible river of creation. A process that may have seeded not just Mars, but Earth itself, billions of years ago. But such a beautiful and profound theory, for all its power to inspire awe, teeters on the very edge of science and philosophy without a single critical element, a piece of hard, physical proof. It is one thing to imagine this grand cosmic exchange, but another entirely to prove it. How could we ever know for certain if a fragment of material was truly a visitor from another star, and not just an unusual piece of our own solar system? The answer to this ultimate question would require a very specific kind of evidence, a signature hidden not in the object's path or its chemistry, but deep within the very heart of its atoms.
The key to unlocking this final, profound mystery, the one piece of evidence that could elevate the theory of panspermia from elegant speculation to scientific fact, lies at the atomic level. To prove that a piece of material is truly alien to our solar system, one must find a signature that could not possibly have been forged here. This ultimate proof is known as an isotopic fingerprint, a subtle but fundamental difference in the very building blocks of matter that serves as an indelible passport, marking an object's place of birth in the cosmos. Isotopes are versions of a single element that have the same number of protons but a different number of neutrons, giving them a slightly different atomic mass. Every solar system, in its entirety, is born from a single, vast and well-mixed cloud of interstellar gas and dust. This primordial cloud has a unique and characteristic ratio of different isotopes for elements like carbon, oxygen, and nitrogen. This ratio is a constant, a shared family trait imprinted upon the Sun, the planets, and every comet and asteroid born within that system. To find material with an isotopic ratio that deviates from this local standard is to find something that is, by definition, not from here. This isotopic analysis is the smoking gun of planetary science. It is the most definitive method for distinguishing extraterrestrial material, like a Martian meteorite that has landed on Earth, from the native rock that surrounds it. In the context of Atlas, this tool would be the final arbiter of truth. If a sample from the object, or even its dust, settled on the Martian surface, could be analysed, and if its atoms were found to hold an isotopic signature that did not match that of our solar system, it would be irrefutable proof of its interstellar origin. It would confirm, in a single, stunning discovery, that we had touched a piece of another star's creation. And here, in this tantalising possibility, the story of Atlas comes to its quiet and unresolved conclusion. The very evidence that would be needed to answer the ultimate question remains, for now, forever beyond our reach. The sample we would need is either locked within the heart of an object now receding back into the endless night, or it is scattered as a faint, invisible dusting across the silent, red plains of a world we have yet to touch ourselves. We are left only with the questions, the echoes of a close encounter that was veiled from our sight. A profound and beautiful reminder that we are but a single, curious shoreline on the edge of a vast, interconnected, and utterly mysterious cosmic ocean.